my name's Lincoln Wallen. I'm currently the Chief Technology Officer for a company called Improbable Worlds. After I left Edinburgh, I pursued what was a fairly sort of standard academic career, working at the University of Texas in Austin and then the University of Oxford in the computer science laboratory. Did a lot of work with industry during that period of time with mathematicians at the college that I was teaching at. And that sort of intrigued me a lot in terms of the problems that industry was facing. And sort of after about 10 years, I got involved in some initiatives with companies like Intel and the university to sort of look at the application of video gaming technology in education, which seemed like a way of interesting students at the time in all sorts of subjects. We looked at mathematics and history and English. The companies I got involved with there were one company called Math Engine and another company called Elixir. Demis Hassabis, who viewers may know is the CEO of DeepMind, works at Google now, was running Elixir Game Studio, building a great open world game. And Math Engine was a software company that basically was looking to build the first simulations library, so physics simulation. I have a background in physics, this was computational, seemed like a good fit, so I jumped ship and ended up in industry building software for video games and engineering applications. And that was really the start. That company eventually was bought by another one that was the biggest middleware supplier. That's software that helps companies build games into the PlayStation 2 and Xbox era of games. And then I ended up in Electronic Arts and spent 4 years building mobile games and building a business in that sort of area. So eventually leaving EA and going into the film industry, that was natural step from video games because film was bigger in the sense of more technology and interesting in that it's offline, involves hundreds of people to create these movies, and animation was becoming transformed by software as well. So I would say actually it's a very, very STEM-centric area, entertainment, digital entertainment. Both video games and film are computer-based, software-based, and can be really enhanced and transformed through software. So very STEM. Yeah, so one of the, when my time at DreamWorks came to an end, it was acquired by NBC Universal. The big achievement at DreamWorks was to really take the production process to the cloud and use sort of distributed computing, supercomputing sort of patterns to create real-time response for the artists. So that pattern of distributed computing, increasing the amount of compute cycles, flops, so to speak, floating point operations that you could apply to a single process, was one of the techniques that Improbable was using to scale video game environments. So the founders of Improbable were looking to do two things: make bigger video games in which more players could participate, but also make it easier to build those multiplayer games and to have more content in the market so smaller teams could afford but also have the expertise to build. And that involved creating a platform that made it easier to do these distributed computing problems. So that was a very similar type of technology and a market that I'd already had experience of at Electronic Arts. So it was sort of a natural fit. And by that time, my expertise is in taking technologies and making them commercial, fitting them into markets, engaging customers, and shaping products rather than technologies. So it was really at the right stage. To the extent I can. Well, one of the applications of larger virtual worlds is in simulating real world environments, sort of digital twins. And while that's interesting from an entertainment point of view, in players in fantastical worlds, or in space environments, or just large scale simulations of cities. Remember, that was what Demis was trying to do with his Elixir company. It's also very interesting to the built environment, to government, and in particular to defence. So defence deploys these days in very complex environments, full spectrum, satellite information, network information, reconnaissance information, social media information, as well as logistics and all the information that goes into running a force or moving things from A to B. So a lot of logistics. So being able to represent all of those processes, all of the data, and do forms of simulation to support good decision making was the application that Defence was interested in. And Improbable built a decision support platform for the MOD, and that really is the core of the business. For each of these application areas, it has a life of its own, and one of the steps in running a business is judging the point at which the different lines of business really need to have their own leadership, their own separate investment, engagement in their market in a particular way. And so keeping them in a single company can sometimes be constraining once you've incubated the idea. So yes, Improbable is concentrating very much on its core business, which is building large worlds for entertainment. And the defence business is now independent and can pursue a more government-centric business. Well, interestingly, Second Life is still going. Phil Rosedale is still running Second Life, and Second Life was one of the primary motivators for the founders of Improbable. What they wanted to do was to make it easier to build experiences like that, so that there could be more of them and more choice for consumers. And in supplying the technology into the market, that was intended to be the business. And that's still the focus for the company. So, one way or another, we actually collaborate with Second Life. And I think this type of service has seen its heyday in the video game industry, in massively multiplayer online games, RPGs, World of Warcraft being the poster child, obviously, but there are many others, Knights of the Old Republic and the like. And I think what Improbable has recently achieved is really massive scale. So we're talking about 15,000 players in a single space, which is, when you compare your typical video game, which strains to get 60 to 100 players in one space, that's pretty massive. Yes, we're using Unreal. So one of the advantages here is that it integrates in tool chains that developers already know how to use. Because a successful technology isn't just about the technology, it's also about how you can get it in the hands of people and do so in a way that they already know how to use it. And I think part of the big challenge with Improbable's technology was overcoming the complexities of the distributed technology and basically improving that to a point where the technology disappears and artists and designers can now really design using some of the really powerful capabilities of Unreal without concern for any sort of underlying complexity. Well, I'm on the XR side of the argument, as in mixed reality and different modes of virtual mixed reality, augmented reality for different applications. So I sit on the board of Vario, which is a Finnish VR XR company. It's probably the leading supplier of high-end headsets into industry, used in automotive, manufacturing, aerospace, you name it. There are headsets out there, and these are some of the highest fidelity experiences that you can get in VR, and most effective in XR, where you're seeing both elements of the real world and virtual world sort of combined and overlaid on each other. So for training purposes, for design purposes, and increasingly for collaboration, Vario's also sort of released a cloud platform to help people see things even just on flat screens on desktops, so that collaboration can be enabled both in and outside the sort of XR space. Well, actually, I would say that I was trained as a physicist, so, and in particular a mathematical physicist. So my passion was for understanding how the universe works, and I thought that's what I was going to do after graduating, and thinking through the sort of next step of PhDs in things like quantum field theory. I came across Alan Bundy's group in Edinburgh, and the mathematical reasoning problem, and the very idea of AI, the very idea of investigating consciousness, simulation of behavior, was at least as big idea as understanding the subatomic structure of the universe. So it actually turned my head, and I decided to come to Edinburgh. Interestingly, my interaction with computers up to that point had been through card systems, programming in Fortran, and it was incredibly painful. So seeing these workstations and direct input and programming models like Prolog was a revelation in terms of how easy and smooth it could be to get machines to do something for you, because I was used to sending the cards in and coming back at the end of the day and it all falling apart. So I could see there was a lot more potential in computing at the time than I'd been led to believe. So I took a leap of faith and joined Alan's group. So that turned me into a computer scientist eventually, but also a logician. It was really, really important that the AI department, cognitive science at the time, machine intelligence, were all part of the same school. And it gave me access to people that were studying linguistics, cognitive science, as well as robotics and mathematical logic and programming languages. So that sort of multidisciplinary environment was really, really important for my development. And I think sort of led me to embrace the industrial world with all of its different skill sets required. Well, I moved to the US for DreamWorks about 15 years ago, so a fair amount of time. STEM-based businesses are challenging to build in the UK because of the access to capital, and that's not about startup. It's really about continuous investment in businesses and the environment in which your customers live. The US has a more vibrant investment environment, but it also has a very sort of extensive commercial environment that works with smaller companies, pulls their technologies through. So the scale is important. The aggressive adoption of technology in the US is very strong, and that helps companies develop. That said, basing a company in the UK can gain access to incredibly great talent. The UK has always been at the forefront of programming. It's always been at the forefront of newer forms of machine design. It still is. And Edinburgh has always been at the forefront of AI. So in some respects, it really depends what type of business you're talking about. Well, obviously, 2023 has been the year of generative AI. It's really taken the world by storm, or at least the chattering part of the world, the news media, pundits, and so on. And lots of companies are exploring use because it's been made available, which is very useful. That said, there's still an awful lot of unknowns about the nature of this type of processing, how to control it, how to make it stable, and how to improve the output. And that's very much a sort of scientific AI endeavor, and is going to require skill sets, from many different universities, including Edinburgh, to actually work through what this technology means. So I've lived through the previous AI hype cycle. In fact, 1983 and 2023, so 40 years ago, feel very, very similar. Then it was the fifth generation initiative in Japan that was picking up on the latest AI technology, which at that time was distributed computing and logic and functional programming, and promising a real transformation of industry. That generated a lot of input, a lot of investment, a lot of expansion of departments, and in particular the AI department in Edinburgh, and it generated a lot of industrial impact. But eventually that hype, passed, and these techniques and technologies became everyday into platforms, solutions, SaaS solutions, and so on. Even your email system, in 1983 would have been seen as a rule-based expert system. Now you look on it simply as Gmail, and the things it does as relatively sort of mundane computational assessment and analysis to make it easier for you to organize your email. So things that first of all seem very, very advanced and cutting edge end up being standard techniques in computer science. That's how the area builds, and AI is no different. I do think, there's a lot of hype about generative AI. I do think Edinburgh is well set to be one of those institutions that begins to look at the reality underneath these techniques and work out where they can be applied, how they can be controlled, and the domains in which it can be most beneficial. One of those domains, and I know Edinburgh is deeply involved in that, are really deep applications, whether that's medicine, science, exploring, materials or diseases or epidemiology. These types of applications have already proved their worth, and Edinburgh is surrounded by other departments that will reach out for this technology, and the collaborative environment is extremely strong here. We actually, at Improbable, use techniques of machine learning to achieve some of the scaling. The statistical behavior of interaction, both visual, logical, physical, in a virtual world, can be looked at very much as a statistical prediction problem, and we use techniques from this tool set to improve the performance of the system. So one of the ways we get scale is using machine learning, but it's in a very tightly controlled optimization application, as opposed to a large data set type of application. At Improbable, some of the content-related projects that we do on behalf of clients and partners sometimes use generative AI to explore creative ideas. So very much in the early visualization, idea generation phases. In general, we craft the visuals for the actual experiences, and those tools are less good at manufacturing objects, models, images to order in a designed, collaborative, multi sort of artist environment. So yes, idea generation, they're great. We've explored using them, and they can work very well. But into the actual production process, they're less effective at this point in time. Yes, humans create the intent. They communicate, collaborate to organize their efforts to produce the fantastic outputs, whether that's a video game or a film. And without that human dialogue, without the imagination that's really framing the outcomes, you don't get the products. So when you then turn around and try to realize that imagination, you can absolutely use advanced techniques to streamline the production. But because the LLMs, generative AI, doesn't manipulate intent, it doesn't operate from an intent perspective, that intent always comes from humans. It's really a little bit like optimizing solutions once you know the type of solution you're really looking for. So it's a very human-centric domain, and artists aren't going away. I think the strength that the UK can draw on is that it's a manageable environment that can, if organized well, combine governmental, regulatory, legal, scientific, engineering, and commercial application to produce the best outcomes for people and for companies. And an environment that can operate like that can become a sort of center of where new things take place, because there's confidence, predictability, and not massive disruption coming from rogue applications, misapplications, where hype goes to die, so to speak, because there is deep understanding. So the challenge for the UK is to bring its scientific, computational, mathematical, legal, and governmental and commercial expertise to bear in a coherent and effective and fast process. Now, can it do that? That's a question of leadership, and it's a question of both government leadership, scientific leadership, and commercial leadership, and the right conditions in which that type of collaboration can be generated. But all those ingredients are in place. It's a small enough market in which that can happen. And if people act carefully, then there's no reason why the UK, smaller than the EU and smaller, of course, than the US, can move very fast in this area. But it has to be coordinated amongst all those elements. Yes, I think a lot of confusion arises in not recognizing that a technology is about understanding, and very difficult to slow down the progress of understanding on the global scene, and probably a waste of effort to try to think about that. But understanding doesn't necessarily lead to deployment, and it's people, governments, companies that make decisions about deployment. And that's where the focus should be, on regulation, on testing, on safety, and on pace. So slowing development of the technology is really a knee-jerk reaction to hyperbole, sort of suggesting that, as you said, Skynet is going to occur in the next month, and suddenly we're all going to be vassals of a computer. That's quite nonsense. The slowness should come, the careful consideration should come in deployments, what you couple these systems to. You're going to couple them to the physical world, you need to be very careful. There's no reason why physical systems don't go through exactly the same testing regimes that aircraft, cars, and so on do for safety concerns. Bypassing those types of tests is wrong. It's problematic, and it will lead to challenges. So just use the regulatory system that we have, be careful in deployment, and we can navigate through this period. Don't get distracted by the science fiction. I think entertainment does a very good job, whether that's novels, video games, or film, of mapping out potential futures and exploring the challenges within them and the benefits within them. And that sort of process of ideation gives us an opportunity to try things out, to try out ideas, to discuss, whether a particular narrative really got to the heart of what would happen if you had this capability or that capability. It's a way of practicing and being and getting advanced notice of the things that we really need to think about. So, examples like Minority Report, the idea of what would it mean to have prior knowledge of a crime? Is it ethical? to convict or stop somebody doing something in advance of them actually crossing a boundary. These are really important ethical questions. In the past, philosophers have asked these questions. It's been academic. Entertainment is a way of having everybody participate in asking these questions. And in a democracy, that's really quite important. Well, I do have a love of the history of science, and so I read a lot in that area. But the main thing I do is I'm a soccer referee or a football referee. So all the stuff about VAR and the challenge to officials, what's a foul, what's not a foul, the laws of the game, it's very close to my heart. So I love refereeing. Helping kids enjoy playing football. And I referee up to sort of 16-year-olds, 19-year-olds. So it's pretty furious. I would help the PG Mole if I could, if they ask for help, because there's plenty of things that can be done to improve the process, and hopefully we'll see more respect for officials and the job that they do, as people get more informed about the laws of the game, which is that simple.